What's cooking good looking, guys? I'm Akif. Here with me is Ryan, Rifat, and Jinsi. Yeah, and today we're gonna present to you our queue time tracker. Okay, so this is our table of contents. So in this presentation, we'll tell you about our project introduction, research background, hardware use, block diagram and flowchart, MicroPython coding, design implementation, and challenges and improvements we have faced and overcame together.
Okay, so for our project introductions, our queue time tracker are there to let the customers know how long is the queue time currently, like on the spot. Yeah, so therefore they can choose either they can continue to shop or they can go and start queuing up. Yeah, next. Yeah, so what are our driving questions? Our driving questions are: how do we improve the efficiency of counter to make it more systematic? Next.
And here is the research. In the first slide, it shows that customers want high quality service experience and companies want low cost to serve. Our project aims to find a middle ground where it makes both the customers and the employer and the company happy. In the second slide, it shows that shoppers will have a negative experience in the retail industry if their experience with the store is not smooth. Let's say if they wait too long. Third slide. In the third slide, it shows that customers are also unhappy when they do not know or they cannot predict their wait times. This is likely due to the fact that they have other better things to do after they buy their items and they may get frustrated. Next slide.
Yeah, so this is our hardware use. So in this project, we use two M5Stacks, 2 pair R sensors, and 1 RGB unit.
I will now be showing you the block diagram and flowchart. This is our block diagram that shows the inputs and outputs the M5Stack will be using and doing once the code runs. Next. This is our flowchart. This flowchart shows what the code will be doing once it starts running. Next.
Okay, so now me and Rifat will share with you our MicroPython coding that we did. So I've done the transmitter. So the code is very simple. Basically, we have created our own timer. And when the first start of the PRR senses somebody, it returns a 1 value. And it will make our clock start. And when the end sensor detects a person, it returns a true value. And it will stop the sensor. It will stop the timer. And all this information is then appended into a list. And the data will be published to Cubitro, and the data will be sent to the receiver through ESP now.
Okay. So this is our receiver code, which I just copied the code from the example given in the Brightspace. So basically, the receiver code is meant to show what color, to fetch what color once the data is sent. That's what, for example, it will fetch rate and set the text to congested once if the data sent is more than 8, or if it's less, then it will show green and change the text to smooth.
Okay, so this is our design implementation. The design implementation is the same as the block diagram. So as you can see here, the transmitter M5Stack is connected to 2 pair R sensors in port A and B, and this is the UI that we have created. It shows the time taken, the reset button, and if the process is starting and is connected. And to the right is after the data is being sent to the receiver M5Stack through ESP now, it will show if the queue is smooth or congested, short or long, with green and red respectively. And for the data, we sent it to Cubitro where it will show the trends, easier for managers to analyze and to send manpower if needed. So this is how we implemented in real life. As you can see, there will be 2 IR sensors at the start and the end. The M5Stack transmitted in the middle, and it will send the data to the top, which is the receiver M5Stack, and it will show light for easier visuals for customers.
Okay, so this is our phone board design, and at the top left is why we think that our queue time tracker is needed. Yeah, then at the top right is real life how we actually connect it. And for the bottom left is just a cartoon design of what we have used, and the bottom right is the QB2.
On to challenges and improvements. The challenges, firstly, IoT was the most difficult part of this challenge because there were a lot of connection problems, but we managed to solve it. And for future improvements, next slide. And for future improvements, the M5Stack can also be implemented with apps that the stores use, for example, an IKEA app that they can check the status of the queue from their phone. And we can also implement machine learning to also reduce manpower and enhance security features of the IoT systems.
Right. Thank you everybody for
Thank you.
listening to our presentation. And now we'll be showing you
Thank you.
our demo.
Demo.
Okay. So this is how our project demo will be like. Rifa will act like a customer. Ryan will be the cashier, and that's the start sensor. This is the end sensor. Okay, let's begin.
So
Yeah.
as you can see, the light here turns green and the average time is calculated here. It also says the customer flow is smooth and it's good.
Here also will show the time taken for each customer. Thank you very much. Thank you.